Okay, so now let's look at how we can solve quadratic equations using a new method called completing the squares. So here's the name of the title of the method, complete the squares. Now this method here, I have to tell you, it's just one of the sub methods that we produce from the square root property, and you're gonna see why I'm calling that a sub method of the square root property. However, you can use this one quite openly. So to proceed with the complete the square methods, now you need your equation to be in the what's so-called the ordinary form. The ordinary form, which allows you to use the complete the square method, is going to be the x squared plus bx equals to a number on the other hand side. You must bring your equation, your quadratic, into the form of an x squared term plus a bx equals c. And I call that form right here the ordinary form. Once again, we have discussed this in class. Now, notice in the ordinary form, the special thing about this ordinary form is that the leading coefficient must always be a 1. So here you can see that I have a 1 lonely x squared term, leading coefficient 1. Whatever the coefficient for b is, I don't care. But then so you have a bx term, you have an x term with whatever coefficient it can be, but the x squared term must be strictly coefficient 1. And then with some whatever number that is, that can be on the right hand side. And I call that the ordinary form. You need to bring your equation into the ordinary form before you have access to the completing the squares method. Okay? And by the way, there shouldn't be that asterisk there for the square. So just completing the square method. So now, to see this in the examples, to have some more detailed examples. Now remember, in class we have talked about what's so-called, in this complete the square method, we also have what's so-called the magic number. The magic number. Okay, and so we discussed this magic number in class. So let's see how we can use that magic number once again in these examples here. So in my example number 1, we want to solve for x. Okay, we want to solve for x. And my first equation here is x squared plus 6x equals 7. So this equation here, right at starting point, it is, let's check, is it in the ordinary form? Yes, it is. I have one single x squared term plus an x term with coefficient positive 6 equals a number positive 7 on the other hand side. So this is just perfectly matched into the ordinary form. See the x squared term, that's the x squared term. Here's the thing about the 6x here, that's just my bx term. And then the number 7 is playing in the role of my c, constant c on the other hand side. So my equation here at this point is in ordinary form. So now I'm just ready to solve this equation here using the complete the square methods. So now before I turn that into before I can complete the square, I need to find what's so-called a magic number. So here it is, magic number. Okay, what's that magic number? To find the magic number, I need to do b over 2. Okay, b over 2, which is, now b, remember, b is my coefficient in front of the x term. So in this problem, my magic number would be, and keep in mind, b over 2 is a formula to find your magic number. So in this problem, my magic number would be equals to 6 over 2. That makes it 3. So that is my magic number. And so now, once I found my magic number, this is how it happens. My equation is going to be on the right-hand side. On the right-hand side, what I need to do is the 7 that's up here on the right-hand side, I need to add 3 squared to it. Now, why squared? What is 3 squared? Where's 3 squared coming from? 3 squared is just simply the square of the magic number we have found earlier. So this is what we do. We found a magic number, we add the square of that magic number to the right hand side of the equation. So that's how I have that. So on the right hand side I have 7 plus 3 squared. The left hand side, and this is how I call it magic in class. You don't have to worry much, but produce for yourself, and nothing is easier than producing for yourself one pair of parentheses with the square that's indicating a perfect square. Now inside of the pair of parentheses, all you have to do is just write for yourself the x, no square, just the x. Okay, and then plus 3. Okay, and keep in mind my magic number has a sign plus 3. So here I put the same way it is, y plus 3, because this was my magic number that I found earlier. That's the magic number I found earlier. Okay, so once again, what I just did, on the left hand side, I produced for myself a pair of parentheses with a square, and then I do x, always there's the x. Nothing else, no square, just the x. And then I put that magic number I found earlier into that spot right there. So I have x plus 3, all squared, now equals to 7 plus 3 squared. 3 squared, once again, I added the square of my magic number to that right hand side. So this is what I get right there. And so, my next step, now cleaning up this equation a little bit, I have x plus 3 all squared equals, now 3 squared is 9, plus 7, that gives me 60. So, at this point, I am quite ready to solve. Now, what's the good thing about this complete the square? The point now is that I have turned my left-hand side of the equation into a perfect square, and equals to a number on the right-hand side. Here, the only access at this point for this equation to solve it is we get back to using the square root property. Okay, so you can notice the square root property is back to you again. Okay, so now the square root property is saying on the right hand side you just simply take positive and negative square root of 16. The left hand side you just simply remove the perfect square, and that gives me just simply x plus 3. And so this equation at this point is telling me that on one hand I have x plus 3 equals to positive square root of 16, which is a 4. On the other hand, x plus 3 equals to negative square root of 16, which is a negative 4. So that once again I produce for myself two sub-equations to solve it. So I have subtracting 3 from both sides of my first equation gave me x equals 1. Okay? Subtracting 3 from both sides of my other equation, sub-equation, give me x equals negative 7. And so here it goes. I have just solved for my quadratic equation using the complete the square method. So what's highlighted in this method here is, first of all, the ordinary form. You need to have one single x squared term with an x term with whatever the coefficient is equals a number on the right hand side. And then the trick to it is we need to find the magic number, and the formula for the magic number is always going to be a b over 2, and in this problem it's 6 over 2, and that gives me a 3. Now notice the sign here is a positive 3, and so what I just did to that magic number is I add that magic number to the part inside of the parentheses here. So on the left hand side I produced for myself one pair of parentheses with a square, and then the x here without the square, and I put that magic number right there. And then on the right hand side I add the square of the magic number, okay, to the right hand side, and I have 7 plus 3 squared. And cleaning up my equation, this is what I get right there. And at this point, that's where I can use the square root property. And that's why I said earlier, the complete the square method is one method that I call it kind of like a sub-method that we produced out of the, that coming straight out from the square root property method. So let's look at example 2, where everything is going to become a little more clear now, to get you really comfortable with the square root, with the complete the square method. So my example number 2, for this, how about we want to solve for x? Solve for x. Okay, and my equation appears to be x squared minus 6x minus 11 equal to 0. Okay, so now in this equation, before you attempt to do any completing the square, you need to ask yourself and check with yourself: is this equation at this current point in ordinary form yet? Which makes it possible to do the complete the square? The answer is not yet. So I have my x squared term, my single x squared term is here, my x term with a negative coefficient, but then I have one term attached to it, so I need to bring this term to the other hand side. Okay, so now to do that, I need to add 11 from both sides, and that gives me x squared minus 6x equals 11. Now at this point, I am ready to use my to start on my complete the square method. Now, what I have is one single square x squared term, one single x squared term with an x term with negative coefficient, and equals to a number on the other hand side. So now at this point, now you can always write this on your side note right here, on your margin of your work. But the magic number in this problem is going to be, remember, b over 2. So that makes it, b in my problem is a negative 6. Minus 6 is my b right there. Okay, so I have minus 6 over 2, and that gives me negative 3. So watch out, be cautious that my magic number is containing negative sign. And so now what I'm going to do to that magic number, on the right hand side of my current equation, my right hand side, my right hand side 11, I'm going to add the square of the magic number. The magic number itself is a negative 3. So I'm going to add the square of that. And I'm adding it to the right hand side. The left hand side is much easier. I'm producing for myself one pair of parentheses with a square, and then with the x inside the parentheses, no square, and now here I just simply put in my magic number, minus 3. Okay? So now cleaning up this equation, I'm going to have, now negative 3 all squared is positive 9, 11 plus 9 is a 20, positive 20. And on the right hand side I have x minus 3 all squared. So once again, the beauty of this problem here is that we have turned our equation here, we have turned our starting equation into an ordinary form where you can solve that using the square root property. You have a perfect square on the left side and equals to a number on the right hand side. So square root property, once again, on the right hand side you do square root of 20 with a plus and minus. The left hand side you just simply rewrite that expression without the square. And so now keep in mind, square root of 20, you can reduce that into 2 square root 5. That's how you reduce square root of 20. And once again, you need to work on your square root skill. And then with a plus and minus. X minus 3 equals plus and minus 2 square root 5. And so, at this point, once again, this very current equation of mine right here is telling me that on one hand, my x minus 3 equals to the positive square root, positive 2 square root 5. And on the other hand, x minus 3 would equals to negative 2 times square root 5. So I have two separate equations, two independent equations to solve for x. And then from each equation, I need to add 3 from both sides. So that gives me x equals 3 plus 2 square root 5. And this is once again where we are done with my first sub-equation. And on the other equation, I'm adding 3 from both sides again. And that gives me x equals 3 minus 2 square root 5. And here I have obtained my solutions for my two solutions for the starting equation, x squared minus 6x minus 11 equals 0. So